Hello, and welcome to Algebra Unit 4-1, Lesson 4. Today's objective is that scholars will graph and apply step functions. So today we are talking about step functions. So first we need to talk about what is a step function. Well, a step function is very simply a piecewise defined function. So it's a piecewise function, but it has constant pieces. The graph looks like a set of steps. You can see right here what a graph of a piecewise function is. It looks like a set of steps. You will notice that in this piecewise function, if I could sort of raise this step up, the hole in this one where it is up to would fit with the dot on the one above it. So you can see that there is no overlap. So there is no overlap between them. Every input has one output, so this is a function. So we're going to talk about certain types of step functions. So there's what's called a ceiling function. So this is a type of function where everything rounds the number up to the next nearest integer. So you'll see here negative 2.4 we're rounded to negative 2. Negative 0.5 we're rounded to 0. 1.8 we're rounded to 2. And you can see that here on the function. Everything just rounds up to the next integer. So even 0.99 would round to 1. 1.01 though would round to 2. This is what the notation looks like for it. You'll notice that it looks like a set of brackets that are sort of missing the top. So a step function looks like that. It's missing the bottom. It's got a ceiling. So that's why it's called a ceiling function. So it has a ceiling. We go up to the next one. There's also what is called a floor function. So a floor function is exactly the opposite of a ceiling function. In a floor function, numbers go down to the next nearest integer. So negative 2.4 would become negative 3. Negative 0.5 would become negative 1. Everything's rounding down to the next one. Negative 0.01 would round to negative 2. Negative 0.99 would round to negative 1. This one is denoted with this symbol right here, where it looks like we have a floor underneath our x. Not to be confused, remember your ceiling function looked like we had a ceiling. That was our ceiling function. And this is our floor function. It looks like we have a floor. Okay. Now let's talk about how we can use these. So let's look at this field trip planning. So some students are planning a field trip. If there are 40 students and adults or fewer going on the field trip, they rent vans that hold 15 people. If there are more than 40 students and adults, they rent buses that hold 65 people each. What function can you use to represent the situation? So we know that each van holds 15 people. Each van holds 15 people. So if we have less than or equal to 40, and you see that down here, less than or equal to 40, we're going to get a van, which is the number of people divided by 15. So that's our function for it. And it is a ceiling function. You have to go up. If you have one too many people, you still have to have an extra van. So if I have 31 people, I need 3 vans. And then we also know that each bus holds 65 people. And if they have greater than 40 people, they're going to take a bus. And the number of buses will be X, the number of people divided by 65. We see that here. More than 40, they're taking the bus. And it's simply X divided by 65. Again, if they have 67 people, they need 2 buses. Okay? So this is how we look at field trip planning. This is what we're looking for. Let's look at this one next. We have a karaoke machine. So Jamal and his brother plan on renting a karaoke machine for a class event. The graph shows the rental cost. So how much should they expect to spend if they rent the karaoke machine from 8 a.m. until 7:30 p.m. So as you can see, they spent $30 for the first hour and then $10 for each hour after. And it's for or any part of an hour. So you see, this is our step function. And this is, of course, a ceiling function. Anything less than half an hour, $30. Any part thereafter, you're going up. Okay? So, if they rent this from... So if they're renting this from 8 a.m. until 7:30 p.m., we think about how long they're renting it for. But let's think first about, we need a function for this. So we have this wonderful graph, but let's write a function. See here, we have our function. You can see that we have, for less than an hour, it's going to be 30 times ceiling of x. So it's going to be at least, x is going to be 1. Anytime x is greater than 1, we're going to round it up to the next whole number. That's what our ceiling function is. And then multiply it times 10 and add 20. So first question. They're going to have it from 8 a.m. until 7:30 p.m. How many hours is that? How many hours is that? We can simply count. 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and then another half. So we've got 11.5 hours. So we're going to be using this function here. So I do 10 times the ceiling of 11.5, which will become what? So if I do ceiling of 11.5, it becomes 12. So I have 10 times 12 plus 20. So 10 times 12 is 120, plus 20 is $140. So that's their price, is $140. Because they had it for 11 and a half hours. So now let's look at, too far. Let's look at something else. So, if the class event ends early, so Jamal could return the machine by 7:05, how much would they save if they returned it by 7:05? So instead of 7:30, they can return it at 7:05. So instead of 11.5 hours, they're going to have it for 11.1. Does that change our price? How much can he save? Well, think about that for a second. Remember, we're looking at a ceiling function. So 10 times 11.1 plus 20 is he give you the same value as 10 times 11.5. Because remember, each of these will go up to 12. So they actually will save, there's no savings. Okay, real quick. Concept summary for you. So we've talked about step functions. It's just piecewise that looks like steps. Here we see a good example of it. In this case, if x is between 0 and 2, it's 4. If x is between 2 and 5, it's 8. If x is between 5 and 8, it's 12. A ceiling function, we have that wonderful ceiling over our x, and it goes up to the next integer. A floor function, we have a floor under our x, and it goes down to the integer below it. Okay, go ahead and work on your classwork and then your mastery check. I'll talk to you later.